Hello friends, welcome to the video tutorial of C programming, and in this video we are going to study the concept of dynamic memory allocation. We will study how to allocate a memory dynamically for two-dimensional array. Now what is dynamic memory allocation? It means allocation of memory at runtime, not at compile time. See, whenever you declare any variable or any array, say you declared variable A, then suppose you declared one array. It can be single dimensional or two dimensional. So here I am declaring two-dimensional array. So whenever you write any declaration statement, and if you declare your array or if you declare your variable, at that time what happens? Memory will be allocated at compile time. Memory will be allocated at compile time. Okay, and compilation occurs prior to runtime. Okay, now as I told you, dynamic memory allocation means allocation of memory at runtime. Okay, means required memory will be allocated after the execution or at the time of execution of your program. Now what is the disadvantage of this method of allocating memory at compile time? See, if we consider this array of size 3 by 3 or of dimension 3 by 3, it can hold 9 elements, right? Okay, but suppose if user requirement is more at runtime, if user want to enter more element or user want to store more element, okay, at runtime we cannot resize our array or we cannot change the size of our array. Okay, so this is the disadvantage, that we cannot resize our array. But suppose if we declare a maximum size array like this, say of 30 by 30 or of 100 by 100. Okay, now what is the disadvantage of declaring your array of maximum size? What happens if you declare your array of maximum size and if user is using only some memory locations? Say in this case, if user use only 2 by 2 array, okay, means user use only 4 locations. So what happened? Rest of the memory location get wasted. Okay, so that is the disadvantage of compile time memory allocation. Okay, so that can be overcome using dynamic memory allocation. Before this, we already saw how to allocate a memory dynamically for one-dimensional array. So this video will cover how to allocate a memory for two-dimensional array. For allocating memory for two-dimensional array, what we will do, we will allocate memory for number of rows. Okay, and then after we will allocate memory for each row columns. Okay, so I hope you understand this. Let us represent it by picture. Now suppose, assume that I want to allocate memory for 3 rows and my each row will contain 2 columns. Each row will contain how many columns? 2 columns. Okay, now first of all I have to allocate a memory for 3 rows. Okay, so assume that these are my 3 rows and I allocated a memory for these 3 rows, and assume that the memory location is something 2200. Okay, now every row will contain 2 columns. Every row will contain how many columns? 2 columns. So let us make a provision for that. Now every row is containing what? 2 columns, and for this column also we are going to allocate a memory dynamically. Now assume that the memory location for this particular part is 3000, means base address is 3000. Okay, then for this it is 4000 and for this it is 1000. Okay, I'm just writing the base address, which is nothing but address of first element, and whenever we allocate a memory dynamically, consecutive memory locations will be allocated. Okay, so what we did, we allocate a memory for our 2 columns and for each and every row. Now our row should point to these columns, or our row should point to this memory location. So let me put a pointer here. Now it is pointing to this memory location, means what? It is storing this address. So what is the base address of this? It is 3000. Now this memory location is pointing here. That means it is storing this address. This memory location is pointing here. It is storing this address. Okay. Now which address we are going to store? Basically there are many addresses. first is this, then this, and this, and this. So how many pointer variables we need? Okay, basically we are going to store the address, remember this thing, and to hold the address, what we need? We need a pointer. We already studied the concept of pointer, so if you are not aware of that part, please watch the video of pointer basic first. So we are going to hold this address, okay, the address allocated for our rows, this address. Okay, now look at here, this address is actually pointing to another address. It is not directly pointing to the value. Actually this address is pointing to the value, right? This address is pointing to another address, and this another address is pointing to the value. Therefore this pointer should be a double pointer. This pointer should be what? A double pointer. Means now assume that we are allocating memory for 3/2 elements and of type integer. Okay, that's why my pointer will be a double pointer and it will be of type integer. And how to declare double pointer? You will declare it in this way. Okay, now I hope you understand why I declared the double pointer. Okay, because my pointer is storing this address and this address is again pointing to another address. If it is pointing to directly a value, in that case I will use normal pointer variable, means single pointer, that is asterisk p. Okay, and now see, these are consecutive memory locations, remember this thing. So here I am considering that every integer is acquiring 2 bytes of memory. So next value will be at 3002 location. Here next value will be at 4002 location. Here it will be at 1002 location. And these are also what? A variables. Okay, here also we are storing the base address, means we are storing the address of first element. This memory also has address, and remember that every pointer acquires 2 bytes of memory. So if the memory location of this variable or this pointer is 2200, then the memory location of next part is 2002 and the next consecutive address will be 2004. Okay, so how many bytes of memory pointer allocates or pointer requires? A pointer requires 2 bytes of memory. Okay, now let us see how to fetch the value. Okay, now we studied the procedure of allocating memory. Now if there are some values here, say 3, 4, 9, 7, 11, 2, okay, and I want to fetch any particular value. Okay, and basically I have only this address, that is 2200, which is stored in P, and I want to access this memory location, that is 4002. Okay, basically this location is nothing but my first row. Okay, first row and first column. Okay, first row and first column. Okay, so how to get it from this? So here what you have to say, 2200 plus 1, say asterisk of this, which is nothing but value at this address, then again you will add 1 to it, and again you will take value at that address. This one is nothing but a row offset. Okay, means I want to read the element at first row and first column. Okay, so according to that you will mention your values. Okay, so this is your row offset, whereas this is your column offset, or you can say row index or column index. Now see, we have only this base address, and from that we have to reach to this location, and then what we want to fetch this value, right? Now let us add 1 to 2200. See, I already told you that pointer requires 2 bytes of memory, and we already studied pointer arithmetic. Okay, while studying one-dimensional array and pointer, I told you that whenever you add particular value, say if you add 1 to your pointer, okay, how it get incremented? It get incremented according to the memory requirement of your variable. Okay, means if my pointer is of type integer and if I add 1 to it, it get incremented by 2. if my pointer is of type float and if I add 1 to it, 4 get added to it. Similarly, if you observe here, my pointer is itself storing another pointer, and every pointer acquires 2 bytes of memory. So if I add 1 to it, what happened? 2 get added to it. So the result of this expression is what? Let me complete a expression, that is 22,002, okay, plus 1. Now let us evaluate this part. So what is the value at this address? The value at this address is what? 4000. Okay, so asterisk or value at address 4000 plus 1. Now we will evaluate this part. Okay, now here we are allocating memory for integer variable. Okay, means this address belongs to integer. So if I add 1 to it, 2 get added to it. So the answer of this is 4002. And what is the value at that address? So value at that address is what? 7. Okay, so let us make this statement general. So what you can say? Star or asterisk of p plus I plus j. Okay, so this statement is equivalent to p of ij. Okay, whereas I is your row index and j is your column index. Okay, so I hope you understand this. Okay, now let us write a logic for allocating a memory or dynamic memory allocation for two-dimensional array. Okay, now due to time constraint, I just completed this code. I declare one double pointer because it is storing the address, then ij variables, then row and column size. Here I inputted the value of row and column also. So this value will be taken from the user. So as I told you, first of all we have to allocate a memory for this row. Okay, and then after we have to store this address in our P. So let us do that. So P is equal to, okay, malloc function is used to allocate a memory. So malloc, okay, now we want to allocate memory for row element, row number of element. Okay, and it is going to store the address of integer type of variable. What is it going to store? It is going to store the address of integer type of variable. So here I'll say size of int star. See, when you say size of int, it means size of integer type of variable, means memory requirement of integer type of variable. Whereas if you say size of int star, means memory requirement for integer pointer. See, look at here. This particular part is going to hold the other addresses. That's why we are allocating a memory for addresses. So that's why I'm calculating the size of integer addresses. Now how many addresses I want to allocate? I want to allocate row addresses, row number of addresses. Okay. Now as we know that malloc function allocate a memory and it returns the pointer of type void. Okay, so we have to convert it to the integer pointer. So int star star. Okay, now why star star? See, we are allocating a pointer for integer addresses. Okay, and our P is of type what? It is integer double pointer. So we have to typecast it into the same type, right? Now we allocated this memory. Now what is the next step? We have to allocate a memory for columns, and that columns allocated for each and every row. So I have to use loop here, right? So for I equal to 0, okay, I less than, how many rows I have? I have rows and I plus plus. So I am starting with 0. That's why I'll end at less than row. Okay, now here we are going to allocate memory for columns and that columns will hold integer type of value. Okay, so I have to typecast it to integer pointer because it is going to hold the integer value addresses, then malloc, then size of. I am allocating memory for integer type of variable, so just integer will appear here. Now how much memory locations I want to allocate? Call memory locations. Now where to store this address? Whatever address I will store, it should go at this memory location, that is 2200, then 22,002, then 2204, 2202 and 2200, right? So for that I have to say asterisk of p plus I. Okay, asterisk of what? P plus I. Now why asterisk of p plus I? Because I want to store this address at this memory location. Okay, if I just say p plus I, it means what? 2200, 2202, 2204. Okay, I want to store the address at that memory location, and this asterisk operator gives you the value at that memory location. Okay, now this will allocate a memory for number of rows. Okay, now what is the next process? Next process is to accept the input and store it in your array. Okay, now you allocated memory. Okay, now assume that these places are what? Empty. Okay, you are going to input the values here. Now how many values you are going to input? Row into column values. So let us write a for loop. So here also we are going to use nested loop. So for I equal to 0, I less than row, I plus plus. For j equal to 0, j less than call, and j plus plus. Now instead of writing a printf statement, I directly write scanf statement. Okay, here your message will appear, that is enter element. Now how your scanf statement will be? See, scanf, my values are of type integer, so here %d will appear. Now you have to give this address. Okay, this address, you already have these addresses. Okay, just you have to mention that addresses here with the help of this p pointer, p double pointer. So what will I say? I'll say p plus I. Okay, and asterisk of this plus j. Okay, that's it. Now what is the meaning of this? Look at here. If my I value is 1 and j value is 0. Okay, what is the value of p? Value of p is 2200. Okay, plus I, which is nothing but 1 here, asterisk of 8 plus j, which is nothing but 0 here. So as we already studied, if I add 1 to it, it gives me 2202. Now what is the value at that address? The value at that address is what? 3000. Sorry, value at that address is what? 4000. Okay, now this will gives me 4000, and if I add 0 to it, it will gives me 4000 only. So that's how we get a address. Before this, just we saw a expression to fetch a value. To fetch a value, what we have to do? We have to add one more asterisk here, then you will get a value. But if you want just address, you have to remove this value at address operator from this. In this way you will get the addresses. Definitely you can manipulate it, practice it, then only it will be more understandable to you. Now while printing, suppose whatever matrix I have inputted, I want to print it. So definitely I'll use nested for loop, similar to like this. Instead of this scanf statement, I'll say printf statement, and for printf statement, what change I have to do? I have to say, now I want to display the value, so I'll say asterisk of p plus I plus j, because here only we saw how to get an address. Now if I say asterisk of star, what it does? It will gives me the value at this memory location. So this is, just remember this thing, this is equivalent statement to your p of ij. Okay, now let us execute this code in code block. Now look at here, all the required variables are declared. Okay, row and column values are scanned, then the memory is allocated for number of rows, then using for loop, memory is allocated for number of columns and for each and every row. Okay, and it is stored at rows memory or row allocated memory, and then after values are inputted for the matrix. Look at the scanf statement as I explained it, and then after the same array is printed. Okay, so same array is printed, just one extra bracket is put. Okay, again one more star is given to fetch the value at that jth location, and just it is adjusted in 3 spaces, and after completion of one loop new line is printed. So let us execute this. Now typing, I'll say just 2 rows and 2 columns. Let me enter the value 11, 22, 33, 44. Look at here. Now let us try it for one more. So let me specify 3 rows and 2 columns. Say 1, 2, 3. Again 1, 2, 3. So it is working fine, right? You have 3 rows and 2 columns. So similarly you can try it for the another values also and check whether it is working or not. And if you want to dynamically allocate a memory and then you want to perform the other matrix operation, your code up to this scanf statement will remain same, and while accessing particular element of your array, instead of writing p of ij, you have to use this statement only, asterisk of p plus I plus j. So remember this thing, that is the only change. Otherwise program up to the scanf part or input part is going to be same. So I hope you enjoy this. If you have any doubts, you can definitely write it to me. Thank you.